Alright, hey guys, so we're back and we're just gonna pick up from where we left off. As promised, we're gonna be starting video number 2 at question 3. So let us begin. Alright, so question 3a, the diagram below shows two pentagons P and Q drawn on a grid made up of squares. Alright, so here's the grid made up of squares. Pentagon is a 5-sided figure. So this has, let me see here, 1 side, 2 side, 3, 4 and 5 side. Okay, that's good. And we are to select the correct word from the following list to complete the statement below. Opposite, reflected, congruent and translated. Alright, so selection process. Alright, so let's look at what each of these words mean and how we can determine if it is related to the pentagon above or not. We're going to be looking at the word opposite. Now, opposite meaning on the other side. Apparently P is the object and Q is the image. Opposite, I think that's just there to it's just like a little distraction. There's nothing opposite about P and Q. Alright. Opposite is up and down, left and right, in and out. There's nothing opposite about this. You can see that there's maybe some kind of turning effect that has taken place. So I don't think opposite is the answer. Reflected. There are 4 types of reflection. Reflection across the x-axis, reflection across the y-axis, reflection across the line y equal x, reflection across the line y equal negative x, reflection across a non-standard line. And when there's a reflection, there is usually equal distance from the object and the image. Alright, there is nothing equal about this, and with reflection it sort of looks like it's mirror image. Alright, so if this was a reflection, let's say across a horizontal line, then it perhaps would look something like this. Let me see here, something like this, or something of that nature. So it would have been like a total mirror image. So I don't think reflection is the answer. Congruent. The word congruent. Alright, so by definition the word congruent means equality, or I should say equality in all respects. So if two shapes, diagrams are congruent, then it means that the area is the same, the lengths of the sides are the same, the angles created by the sides are the same, the perimeter is the same. It almost means like if I take object or image P and try to turn it around, I should be able to fit it exactly onto P, and that kind of looks like what the answer is. So I'm looking at this here. I definitely know it's not translation, and I'm going to tell you why in a moment. The answer is congruent. Right, if you check this section of the diagram, you can see here that this has 1, 2, 3 with these 2 half squares, 4. This has 1, 2, 3 with the 2 half squares, 4. So this section in here is exactly equal to the area here. Then you can see that this part is equal to that part. So by process of elimination, the answer is congruent. Translated definitely is not the answer, simply because when translation takes place, the object and the image looks identical in terms of their orientation, in terms of their appearance. It may be at a different place, maybe it's there, maybe the object is here, or it's down there somewhere, or over here somewhere, but it won't change its orientation. Here you can see clearly that the orientation of the image Q has changed. So by process of elimination, congruent is your answer. All right, so pretty good there. Fill in the blanks. All right, so let's move on next now to, so pentagon P is congruent. Let's write that in. Congruent to pentagon Q. Give the reason for your choices in AI. All right, so we could just write what I had written earlier, that pentagon P is congruent to pentagon Q since the area, the length, the perimeter, the angles are the same. So you could mention all of that. You could mention any of the above, right? You just need to make one comparison. All right, so that's good. So let's move on now to the next question. The diagram below, not drawn to scale, shows a pentagon VWXYZ. So VWXYZ. Okay, alright, so we're looking at the pentagon. And in the pentagon, YZ is parallel to XW. Let's identify that. YZ, this is YZ here. YZ is parallel to XW. Now once I see that, alright, let's continue reading. So YZ is parallel to XW, and YX, this is YX right here, and that is parallel to VW. Angle XYZ is 114, I got that here, and while angle VZY is 98. What are we required to find, guys? We are required here to determine the value of the angle WXY. So we're looking for this angle right here. Alright, ladies and gentlemen, so let's talk about what are some of the things that you should really be looking out for when it comes to a question like this. Now, I see one main key element in this question here, and it's this word right here, parallel. And once I see parallel lines, there are two things that comes to my mind, which obviously should be coming to your mind, is alternate angles. So alternate angles. And another thing that comes to my mind is co-interior angles. So those things come into my mind. What I'm doing is that I'm using the clue given in the question here, alright, to identify key points that I'm going to have to be using. So having a look at this question here, I want something that's going to help me to find this angle here. Now I could perhaps create a Z here by connecting point Y to point Z. Sorry, point Y to point W. So I'll get this looking Z thingy here. But that's not going to help me, because all that is telling me is that this angle here is equal to this angle here. So that's not going to be much of help. Alright, so I guess that won't work. Let's look at another option. Let's look at the other Z angle here. So I could have that looking Z looking thing here. So I have a line that's running through the angle that I need, and you cannot assume that it's running through the middle. So we don't know what that is. So we don't know what that is. We're just exercising all the different things, because the first clue here is alternate angle, so this angle would be equal to a part of the angle that I want, and I don't have enough information here. Let's see if you could try another Z here. let's try this, the Z this way. Yeah, did we? So we could have that Z looking thing here. And again, this angle over here will be equal to that angle, but that's not going to help me in any way. So even with those parallel lines, the Z angle, the alternate angles is not helping me. Let's try our co-interior angles. Now, co-interior angles are angles that are formed on the same side of the transversal that cuts the parallel lines. Now, what I'm looking at here, and I think I found my answer, is that they earlier said that YZ, right here, YZ is parallel to XW. Alright, so these two lines are parallel here. So with that said, then if I were to extend YZ this way and extend WX that way, I could create what is known, I could create another alternate angle here. So let's look at this alternate angle here. It is this, this, and this. So I know that right away that this angle here is equal to this angle on the outside here, which is 114. So I'd have to write that first. And then to find this angle here is just taking the 114 from 180. Alright, so that's one way of using the alternate principle. Let's do that. Let's do that. So it's just one mark, so we can choose either method. Alright, I'm going to show you the other method shortly. So we could say that angle, no, let's write it this way. The external angle of angle WXY is equal to 114. Alright. And then we'll just give a reason and we'd say alternate angles. And then conclusion, therefore angle WXY is equal to 180 minus 114, which is then equal to 66 degrees. So this angle would be 66 degrees. Alright, and then the reason for that simply would have been angle at a point on a straight line measures 180. Let me repeat that. The reason for getting the 66 degrees is simply because the angles at the point on a straight line, the straight line here is WX with the extension here. So this is a straight line here and that angle measures 180 degrees. So therefore take 114 from 180 and we get that angle of 66 degrees. So that's pretty good. So this angle right here is 66. We could also look at the fact that the 114 here is co-interior with the 66 because these two lines are parallel and this is the transversal. So the angles are on the inside and they're on the same side of the transversal. So we could say that those two angles are co-interior to each other. Therefore, we could take 114 from 180 and we would still get the 66. That is if you know how to identify co-interior angles. So, pretty good for you dear guys. Alright, so hope you got that. Alright, so let's look at finding the angle ZVW. The angle ZVW. Let's look at our diagram here. Okay, so let's do some clearance here. So this is 66 here. ZVW, where is that? So ZVW, this angle here. Alright, ZVW, we could find that angle. Now, I'm saying here again that VW or WV and YX are parallel lines, so therefore the angle here is also equal to 114. Alright? Because we're using the same principle as we did with YZ and XW. Alright? So since these two were parallel and is a transversal cutting it, and we see that these two angles on the same side of the transversal adds up to 180, then it's a similar idea where these two lines are parallel, that is the line VW and YX, and these two lines are on the same side of the transversal WX. Then we could say that angle, let's write it, angle YW X is equal to 180 minus 114, and that therefore is equal to, it's 180 minus 66, because these two angles are coincident to each other, so that's going to be equal to 114. Most of you probably are saying, why couldn't we have said that this angle and this angle is equal? There's no evidence. That's not always the case in a pentagon. So we can't make that mathematical assumption that the angle facing each other in a pentagon are equal. You can't say that. And we can't say that this is facing this, because if this is facing this and this is facing this, then what is this facing? So lots of things here to consider. So I think this is the only way. So this is 114. Now, there's something you need to know about a polygon. Alright? So, the sum of all the angles, or I should say sum of all the interior angles, sum of all the interior angles of a polygon can be determined by the formula 180n minus 360. Alright, so that's 180n minus 360. That's a formula for the sum of all the angles, the interior angles of a polygon. So when I take this angle here, this angle, when I take this angle, 98, 114 and 66, and when I add them together, I should be able to get the sum of all the angles in a pentagon. Now the n in the formula here represents the number of sides for the polygon, and in this case we're dealing with a pentagon, so that's 5 sides. So if you do the math here, that's 180 multiplied by 5 minus 360 degrees. So if we go on our calculator and we press 180 multiplied by 5, that should give us 900 minus 360 degrees. Let's subtract that, 360. So that's equal to 540 degrees. So all the angles in this pentagon here measures 540 degrees. Now we know 4 of the angles. We know that this is 98, we know that this is 114, we calculated this to be 66, and we also calculated this to be 114. So just using very basic geometry here, that since the sum of all the angles is 540, therefore the angle which we're looking for here, which is what is it that they ask us for? The angle what? ZVW. So therefore angle ZVW is going to be equal to 540 minus the sum of all the angles that we have, which is going to be 98 plus 114 plus again 114 plus the 66. Alright, now let's add that up on our calculator here, and we're going to be getting, let's see here, 98 plus 114 plus 114 again plus 66. That gives us a total of, let's double check that again guys, so that's 98 plus, okay, I did make a mistake, I inserted 14, so 98 plus 114 plus 114 plus 66, that's going to give us 392, so that's 540, so that's 540 minus 392, and that will pretty much give us the answer to the angle that we're searching for. So that's minus 540. That's going to give us an angle of 148 degrees. Alright, so that's pretty much how we would go about calculating that. So some knowledge was here. Something that doesn't come up a lot is the fact that the sum of the angles in a polygon, let's just highlight that here. It's very important information. Alright, it's 180n minus 360. Some books might tell you it's 180n, 180 open bracket n minus 2. It's the same formula. And there are other variations to it also. Alright, so hopefully you guys got a hang of that question there. Alright. Alright. Let's move on now to the next question. Let's make sure that we check that there's anything that's left off. I think that's it. So I'm going to go on to this question here. Alright guys, so part C. The letter A and the point 66 are shown on the grid below. So let's identify. We can see the letter A here. Alright, and we can see the position 66, so that's 6 to the right and 6 upwards. Alright, so we've identified those positions. What are they asking us for, guys? It says on the diagram, draw accurately each of the following transformations. Now what we're looking for is an enlargement of the letter A. So A is our object, and it's by a scale factor about the center 66. Alright, so our job here, guys, is to enlarge the letter A from the position of 66. Alright, now usually what happens, guys, and if you check the different past papers over the years, you'll recognize that most of the time, or most commonly, what they'll do is that they'll give you an object, give you the image, and ask you to locate the center of enlargement. Alright, and most of the time you're going to always find that the center of enlargement is in the center. For most cases, most demonstrations, that's what we do. In this case here, you're doing the reverse. You're actually using the center of enlargement to find the actual image. Now in order for us to do this, we're going to use the same process, the same methodology that we would do to find the center of enlargement. So had you had the image somewhere and the object somewhere, we would have connected vertices or corresponding vertices. So let's say that this was A here. Let's say, for example, this was the enlargement of A. We would connect this to this, right, because this corresponds with that. We will connect that with that over there, and we will connect that with that over there, and then by extension, wherever they meet would be the center of enlargement. Alright, so that's how we naturally do it had we had the image. But we don't have the image. What we have is the object and the center of enlargement. So let's get into it. We're going to do the same procedure. I'm going to zoom it up here for you guys. We're going to use the same procedure, and please bear with me here. I might be a little bit careless in terms of like hopefully I draw it straight enough. I'm going to draw a line from the center of enlargement here. I'm going to draw it through this vertex. I'm using these three vertices here to assist me. This vertex here, this vertex here, and this vertex here. Alright, those are the vertices that I'm using. And what I'm going to do here is that I'm going to draw a line from the center of enlargement here. Okay, let's just get it steady. Hold on, guys. I want to draw it as straight as I can. It's a little wobbly. Okay, just a second, guys. Hopefully I can get it. Alright, so I think I have it just enough. It's a little wobbly, guys. Hold on. Should be easier for you though, because you guys are going to be on the physical paper. I'm on a screen here, guys. Alright, so it's a little wobbly, guys. It's a little wobbly. Forgive me if I'm moving a bit slow here. I think I have it. Uh-oh. Alright, hold on, guys. I might have to do this freehand. And here you see here, there we are, we have our pencil up. Alright, so I think I have it just about now. Alright, so it's not as straight as I would like it to be, but that's a straight line there. I'm going to draw another one from here to here. Alright, so once I draw it through the positions, I'm extending it as far as I can. I'm going to draw another one here. Alright, so I got it pretty good. That's not bad. Thought I would have made a mess of that. So I've drawn extended lines from the center of enlargement through 3 specific vertex of the shape. In this case, the shape is really like, it's like a triangle, but well, it's just the letter A. Alright, so what's going to happen after that now? We know that the scale factor is 2, so we know that the positions from the center of enlargement, towards the vertex of where I've drawn my extended lines through is going to be doubled. So if I check the distances from the center of enlargement to the top of this letter here, of this object here, I know that I'm going, let's see here, 1, 2, so that's -2 to the left and -2 down. So I know that the point, let's call this, let's just name this, let's just give it a name, let's just call this A, let's call this B, let's call this C, just for reference. So now the position that I've labeled A is going to be A, which is going to be -2, -2, that's going to be multiplied by, alright, so that's going to be -4, -4. So that's the position of A prime. Let's just write the calculation a bit better. Alright, so A prime or A dash is going to be equal to A multiplied by the scale factor. Alright, so that's going to be equal to -2 multiplied by 2. So that's going to be equal to -4, -4. So from the center of enlargement, I'm just going to go across -4, -4. So 1, 2, 3, 4. 1, 2, 3, 4. And if you realize here, guys, let me just use a different ink here. If you realize that it lands exactly onto the line that extends from the center of enlargement through A. So I know I'm on the right track. Now let's do B. From the center of enlargement 6, 6 towards the position that I've labeled B, that's going to be, let's see here, 1, let's see here, 1, 2, 3, so that's 3, so that's -3, and 1, 2, 3, 4, so that's -3, -4. So once again, B prime, let's see here, B prime is going to be equal to the position of B times 2 again, which the position of B is, as I said, -3, 4, and that's going to be multiplied by 2, so that's going to be equal to -6, and this is -3, -4, I'm sorry, so that's going to be -6, -8. So from the position, from the center of enlargement C, I'm going to be moving -6, -8. So 1, 2, 3, 4, 5, 6. So that's -6, -8 now. 1, 2, 3, 4, 5, 6, 7, 8. And as you can see there, guys, I've landed right onto that extension line right here. That is on the line extended through the center of enlargement through B. Alright, so those white dots represent part of what my diagram is going to look like. From the center of enlargement C to the position on the diagram that I have labeled C, alright, that's going to be 1. So I'm going to go across -1. and I'm going to go down 1, 2, 3, 4. Alright, so that's 4. So that's 4. So negative 1, negative 4. Alright, so let's get to that. So C prime, my C prime, is going to be equal to the position of C times 2. And position of C was negative 1. Was that negative 1, 4? Was that the case? Let's double check. Negative 1, 4, 1, 2, 3, 4. That's correct. Negative 1, negative 4. And that's going to be multiplied by 2, which works out to be negative 2, negative 8. That's the position of my C prime here. So this is going to be my A prime, B prime, and C prime. So that's negative 2, negative 8. Let's move it up. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. And it lands right there. Oh, not good enough. Okay, right here. Alright, very good. So that's the position there. So that's negative 2. Let's double check and make sure that we're right. 1, 2, and 8. So it's on the line. Alright, and that's going to be my C prime. So to complete the shape here under the transformation of scale factor 2, I should have something looking like this, or you should have something looking like this. I'm not sure. This is a little bit off, I think. I need to check the position. This is going to be 1, 1, 2, 3, 4. So it's going to be, so negative 1, negative 4. So that's negative 2. 1, 2, 3, 4, 5, 6, 7, 8. Alright, I think I'm right, but it looks a little bit off. Okay, so I see where the error was. The error was actually with my position on A. Alright, I don't think A is going to be here. I think that my A. Alright, so guys, just ignore this point right here. Alright, so let's ignore that. I think I made a mistake. When I actually let's identify this error, guys. It is negative 4, negative 4, but I think I went a bit too far. I think I moved the position from A prime. I moved it from A instead of the center of enlargement. So this should have been from here. It should have been from here. 1, 2, 3, 4. 1, 2, 3, 4. So A would have been actually right here. Alright, so that's my A dash. So please ignore this position here. Alright, please ignore that. So here's my shape that I'm looking at now. There we go. And we're gonna have it here. And then we're just going to have it right here. Alright, and that's the position of my A. Alright, so this is how you'd go about the process. Alright, hope that wasn't a bit confusing for you guys. Alright, my screen is a bit slippery, so sometimes it gave me a little bit of trouble just to go through the process. But for you, you're on an actual graph paper, so you should place your ruler down and do exactly as I told you. Follow those instructions and you should have a smoother process than I have. Alright, so that is how you get that 2 marks right there. Now they're looking for the translation of the letter A using the vector t, which is minus 3, 2. Alright, so I'm going to erase this section right here, guys. Make sure that you guys have that down. And so the formula for translation, guys, is O plus T is equal to the image. So it is the object position plus the vector of translation that will give you the image of the letter A. Alright, so we want to know where A is going to fall. So I'm going to still use those 3 points from my position A. Alright, I'm going to use the point here and here and here. So A is going to be, let's just see, we're going to have to find the position of A using the center of enlargement. Sorry, using the center, the origin right here, which is 0, 0. So that's how we're going to get the actual position of A. We can't get the position of A using the center of enlargement because we're no longer dealing with center of enlargement. We are now dealing with the actual position of A. So A is located at 4, 4. You can see 4 to the right and 4 up. So let's write that down. So A is 4, 4. B is going to be 3 and we're going to go up 2. Alright, so B is 3, 2. And C is going to be the position of 5 and we're going to go up 2. So 5, 2. So those are the points that represents my object. I'm not going to add that to my translation vector, which is -3, 2. And I'm going to add it like I'm adding matrices. Alright, so I'm going to be adding all the top numbers here to -3 to get all the x values of my new image A after translation. So 4 plus -3, that's going to give, so 4 plus -3, that's going to give me 1. 3 plus -3, that's going to give me 0. 5 plus -3, that's going to give me 2. Alright, at the bottom now, we're going to add all the bottom numbers to 2. So that's 4 plus 2, that's 6. 2 plus 2, that's going to give me 4. And 2 plus 2 again, that's going to give me 4. So this is going to be the image of my letter A. I'm going to call this A dash dash, B dash dash, and C dash dash. Alright, that's going to be the new position of the letter A under the translation. Let's plot those. Alright, did they say must draw it? It says on the diagram draw accurately. Okay, so we're going to draw it. So 1, 6. Let's zoom it up a little bit here. So going across 1, let's use a different color ink now, guys. Let's use green. So going across 1 and going up 6, I think I'm going to be at this position right here. Green's a bit dull, guys, so let's use something a little bit brighter. Let's use maybe blue. Yeah, we could use that. Alright, so that's good. So that's the first position. And then we're going to go from 1, 6, we're going to go 0, 4. So 0, 4 is going to be 0 in the center and 4 up right here. I remember that we're translating this A, guys. We're not translating the big A, we're translating the small A. And then we're going to go 2, 4. So 2, 4. So 2 to the right and 4 up right here. Alright, just going to draw the line like that, and that is going to be the translation of the object A right here. Alright, and that is how we get it. That's what's required to get to that answer there. Now, hope you guys got that. A little tedious, I don't know. Let me know in the comment section, guys, if you are able to get close to the answer. We're going to move on next to question number 4. And now we're at this point here. So the function f is defined as f at x maps onto 3 minus 2x. The diagram below shows the mapping diagram. The diagram below shows the mapping diagram of the function f. Determine the value of a. Alright, so these are all the values here of x, and these are the values that comes out once each of these values are inputted inside the function. So this is the input, this is what's taking the input, these are the outputs. So we have We know what the value is when 0 is mapped into the function, we get 3. When 1 is mapped into the function, we get 1. When 2 is mapped into this particular function, we're going to get -1. But we don't know what the value here is. So naturally, this is pretty much telling us that we just need to replace -1 into the function here to get the value that comes out here. So that's going to be to substitute -1 for x in f x, and that's not f r x, it's just f at x. Alright, so we're going to do that. It's going to be 3 minus 2 times -1. Let's write this minus a little bit better, guys. So 3 minus 2. So that's going to be 3 -2 times -1, that's +2, and 3 plus 2 is actually equal to 5. Okay, so a is equal to 5. Alright, pretty good, guys. Not bad. Let's move on to the next question. Determine in their simplest form an expression the inverse function f minus 1, the inverse of the function f, which is f minus 1x. Alright, now to do this, guys, there are just pretty much 3 steps. You might have seen when I told you in the previous video that the 3 steps for the function is replace the function notation with y. So whatever represents the function, we're going to replace that with y. So we know that the function was f at x maps onto 3 minus 2x. So we're going to replace this guy here with y. So therefore we're saying that we're going to replace the arrow with an equal sign. So y is then going to be equal to 3 minus 2x. What's going to happen next now is we're going to interchange. So this is step 1 completed. Step 2, we're going to interchange x with y. So we're going to interchange x with y. So what's going to happen is that the y will become a x and the x will become a y. Alright, so that's step 2. And step 3, we're going to make y the subject of the formula, or the subject of the equation. Make y the subject. Don't think I've spelled subject right, guys. So we're going to make y the subject of the equation. Alright, so to make y the subject, we're going to have to get y to be positive, and we'd like it to be on the left hand side. So we have a -2y here. We could just add 2y to both sides, or what most persons will say is that bring the 2y over here. So -2y will become 2y, and that's going to be equal to 3 was not moved. So because the y came over, the x has to go back over. So we're going to subtract x from both sides. That's 3 minus x. And we're just going to simply divide both sides by 2. So we're going to have 2y divided by 2 is equal to 3 minus x. Oops. 3 minus x divided by 2. So our final answer here is going to be that y is equal to 3 minus x divided by 2. Once you have gotten y to be your subject of the equation, then therefore you've basically found the inverse. Alright, so I always like to tell a student that they should just make the conclusion that therefore f inverse x, which is what they ask us for, is equal to 3 minus x divided by 2. I like doing this because what happened is that they ask us to find f minus 1, but the procedures that we're using here to get to our answer is pretty much where we have to just kind of do some alterations to the thing and make y. So once we know that once we have gotten y to become the subject of the formula, then we know that we have automatically obtained our inverse. Alright, good. So we're going to move on now to the composite function f square x. So we're looking for the composite function f square x. Now what this means, alright, usually we don't see this kind of notation very often, f square x. What we most likely or most often will see is something looking like f into fx or fx into f, right? That's what it means. So this f square x, it's an unusual representation, never seen it before, but we know basically that it means that we're going to take the function f and we're going to replace the x that is in the function f with the actual function f. Sounds a bit confusing. Let's put pen to paper here. So we know that the function f is actually equal to 3 minus 2x. Alright? And we're looking for f square x. So what this means is that we're going to take the actual function f and we're going to replace it back right where that x is, right here. So we're going to have 3 minus 2. We're not going to write the x. We're just going to replace the x with the function that you see that I've circled here. So that's going to be 3 minus 2x. So we're putting a function into a function. In this case, we're putting the function back into itself. So by simplification, this is going to be 3. Do not say 3 minus 2, guys, because this 2 immediately precedes the bracket. So we're going to have to distribute that 2. So it's going to be 3 minus 2 times 3 is 6. Negative times negative is positive. 2 times 2x is 4x. Then now we can do the necessary subtraction. So 3 minus 6, that's going to be negative 3 plus 4x, or some persons will say 4x minus 3. Alright, and that's going to be your answer for the function f square x. Alright, so hopefully you guys got a hang of that. Moving on to the next question. Oh, there's a question at the bottom here. So we have to state the value of f minus 1 minus 2. So this is telling me here that I should basically take the value minus 2, which is representing the value x, or representing the variable x. We're going to replace that minus 2 wherever the x is in the inverse function. That should produce a value. And then once we have obtained that value, we are now going to do another substitution into the function f. So it's like a double substitution. Now one of the best ways to write this here is f inverse minus 2 implies that we're going to take the function f and we're going to replace, we're going to find the value of f inverse minus 2. Alright, so now f inverse minus 2 means that we're going to take the f inverse function, which is what we just found up here. We found the f inverse function here. Let's make, say, f inverse x is 3 minus x over 2. We're going to replace negative 2 wherever we see that x right here. So that's going to be 3 minus whatever x is down here, which is minus 2. So that's going to be 3. So that's going to be 3. Forgive me, guys. Hold on just a second here. So it's going to be 3 minus 2 over 2. Alright, so we should get an answer here of 3 minus minus 2, that's going to be 5 over 2. And that's going to be the value of f inverse minus 2. Now we're going to take this value now and put it right here. So this is going to become f, and we just work this f minus 1 minus 2 here, and we got 5 over 2. So we're going to take this 5 over 2 and replace it with the x that is in the actual function f. And we had initially told you right here that the function f is 3 minus 2x. So we're going to say that's going to be equal to, or that implies that this is going to be 3 minus 2 times 5 over 2. Alright, because it's 3 minus 2 times x, and x in this case is 5 over 2. So that's going to be 3 minus 2. Okay, we can cancel here and here. So we're going to end up with 3 minus 5. So that works out to be negative 2. Alright. Now, there is a rule that governs the function principle. And if you're able to identify that, then you wouldn't have to do this much work for 1 mark. And the rule is this: if you have a function and you replace its inverse in the function, then what you're going to get is going to be x. Alright? If you know, that's just something that you have to know. So if you're able to spot it, then you could just simply write down that the answer is going to be minus 2, like what we got here. But if you don't know that function rule, then you're going to have to go through all this process here so as to get your answer only for 1 mark. So you have a choice, guys. Alright? Let's move on to the next question. Let's see here. Are we good? Are we good to go? So what we have here, guys, is part B. It says, using a ruler, draw the lines x equal a half. You have to also draw the line y equal x, and you have to also draw the line x plus y equal 5 on the grid table below. So we have our x-axis here, and we have our y-axis already drawn, and the scale that we're going up by here is a 2 to 1 scale. So for every 2 squares represent 1, another 2 squares represent 2. Same thing. So the scale on the x-axis is the same thing as the scale on the y-axis. Alright, so we have to draw those 3 lines there. Now the line x equal a half is just the line that is going through a half on the x-axis, and that's going to be a vertical line. So since this is 1 right here and this is 0, then half must be directly in between. Alright, so we're drawing a line looking like this. Let's use a different color ink here, guys, so we can see clearly the difference. Let's do orange. Let's do orange. As x equal a half. Let's label it x equal a half. Let's just remove it from inside. We're going to need to read that later on. So x is equal to a half. We're going to also draw the line y equal x. Now y equal x is a line that runs from the origin, which is right here, 0 0 right here, and it goes through all the vertex of the squares to the other corner. Alright, so not sure how accurate I'll be here, guys. A little bit off, a little bit here. I it looks like I'm accurate enough. Well, yes, this is the line y equal x. Just gonna extend it a little bit here. So it's really supposed to go exactly through the center right here. Alright, so it's going to be a line y equal x, and then the other line x plus y equal 5. I can tell you off the bat that line is crossing 5 on the y-axis and it's crossing 5 on the x-axis. But most of you guys probably will be wondering, how did I get 5 on both? Does it work all the time like that? Yes, it works like that when the coefficient of the x and the y is 1. Then whatever it's equal to tells me the intercept on the x and y axis. Now it doesn't work if the function or if the line of the equation of the line looks like, say for example, 2x plus 3y equal 10. You cannot say that it crosses 10 and 10 because the coefficients of the x and the y are not equal to 1, so it doesn't work like that. For this one, clearly because this is x and this is y and the coefficients are 1 and 1 and it's equal to 5, then we know that it's crossing the y-axis at 5 and crossing the x-axis at 5. If you want to actually know how to get it, to calculate the value, we could say that when x is equal to 0, we substitute 0 for x into the x plus y equal 5, so that's x plus y equal 5. So 0 plus y is equal to 5. So y is equal to 5 minus 0. Y is equal to 5. Alright, so we can find the value of y by replacing x with a 0, and similarly we can find the value of x by replacing y with a 0. Alright, so I'm not going to go through all of that. We know it's going to cross at 5 and 5, so we're going to just get our ruler here and straighten up. Alright, so I've done that to the best of my ability, so you should have something a lot more accurate than I have. Alright, so we have drawn those 3 lines. That's 1 mark. I think 6 is a bit stingy with these marks though. I think that it's worth at least 2 marks, maybe 3. Anyways, on the grid, label as R the region where x is greater than a half, y is greater than or equal to x, and x plus 5 is less than, x plus y is less than or equal to 5. So let's try to find that region there. Let's just use blue for our region, or let's use white for our region. So greater than x, so x is greater than a half would have been here. Let's shade over this region, so that's to the right of that line. Alright, I'm going to use a different color ink here. Let's use red. No, let's use yellow. Alright, so I've shaded greater than x. So x is greater than a half. I've shaded this section here. Y is greater than x. So here's the line y equal x. So greater than would have been above it. Alright, we're looking for the region where all 3 colors are going to be in at the same time. And let's do blue, or let's do green. We're looking for x plus y is less than or equal to 5. So less than this line here, it's going to be below it. So the region, if you look carefully, the region where the white shaded, or the white shade, the yellow shade, and the green shade comes into play is going to be right here in this region. So we're going to label that R. and that's the region here. So we could just shade that region there and leave it R. Alright, and that's that region that satisfies the 3 inequality. Right, so that's not bad. That's a lot of work for 1 mark though. Okay, oh, so we actually got 3 marks for drawing the lines. That's good. And we got 1 mark for the shading the region. So fair enough. I think that we could have maybe gotten 5 marks, but it's fine. It's a little bit stingy though, but that's okay. We'll move on to the next question. Alright, so we're at question 5. Now we're going to make this question be the last question for this video. Alright, so this is going to be video number 2. We'll upload video number 3 going from questions 6 onwards. Okay, so this is the last question for this particular video. Alright, so question number 5 here. 60 students took an algebra test which comprised 15 multiple choice questions. The number of correct answers that each student obtained is recorded in the table below. So on the left we have the number of correct answers, and on the right we have the number of students who got those correct answers. So interpretation is telling me here that 6 students got a total of 8 answers right out of the 15 multiple choice questions. 14 students got a total of 9 out of the 15 multiple choice. 2 students got 10 out of 15. 6 students got 11 out of 15. 2 students again got 12 out of 15, and so on and so forth. You have to use the table, or it says using the table determine the number of students who had exactly 13 correct answers. So that's easy, because this is the number of students who got 13 correct answers. So the number of students is actually equal to 11. Right? That's it. Straightforward. 11 students got exactly 13 answers. Now we're looking for the modal number of correct answers. Alright, the modal number of correct answers. So we want to find out, and this is a tricky question because mode is basically the frequency that occurs the most. Alright, so a lot of students might make the mistake and say, alright, if the mode is the highest frequency, they might say that 15 is the answer. They might say that 14 is the answer. Alright, because you're looking at the fact that the number of correct answers could be the frequency, or some person might be thinking that they ask for the modal number of correct answers, so they're looking at the fact that 14 students was the highest amount of student. But in fact, if we're looking for the modal answer, what we're looking for is the answer, or the number of correct answers that were gotten or that were received by the most students. So the most students that got a particular answer was 14, but the modal correct answer is 9. Or the modal number of correct answers is 9. Why? Because 14 was the highest amount of students that were recorded that got a particular a certain amount of answers, and that modal answer is 9. So we had the most students getting 9 out of 15. Alright, you have students that got 15 out of 15, but it was not as much as the amount of students that got 9 out of 15. So therefore our answer here is going to be 9. It's just a 1 mark question, guys. Alright, so the median number of correct answers. Alright, so tricky little question here, guys. Tricky little question. Median. Alright, so the median. So if we want to find the median, guys, remember that the median, let's make a note here, the median is the observation that occurs in the center. So median is the observation that occurs in the center. Now this is a lot of numbers. This is 60 numbers. For me to, if you were to think about this from a handwritten perspective, we'd have to write out 8 6 times, 9 14 times, 10 2 times, 11 6 times. That's going to be a little bit tedious for just 1 mark. So there has to be a shortcut to this. Now we know that if there's an even number of distributions, then there's always going to be 2 numbers in the middle. Alright, and we might have to add those 2 numbers and divide by 2. Now if I want to find them, here's how I think I should do this question. I'm thinking maybe we could just simply find the position of this median value. Alright, so I'm going to try to find the median position here. So the median position. So I'm trying to locate at what section throughout the 60 distribution of different numbers will the median be located. And I can attain that by simply using the formula n plus 1 divided by 2, where n represents the number of observation. Now we know that there are 60, it says here that 60 students took the algebra test. So we know that there are 60 different scores, or 60 scores where some are the same and some might be different. So that's 60 plus 1 divided by 2. That works out to be 61 divided by 2. So the median is located at the 31st.5th position. 31st.5th position. So this tells me here that the median value is located, so the median value is located between the 31st and the 33rd and the 32nd value. So I need to find out what is this 31st value and what is this 32nd value, and then I'll just add them together and divide by 2. So I think that's the best way of doing this. So how can I find the 31st and the 32nd value? Well, we kind of have an easy way to this, simply because these numbers are written in order. I can say that 6 8, so I can cross this 6 out, so I've already crossed out 6. I'm trying to get myself all the way up to the 31st value, so I'm already at the 6th value here. Cross out another 14 numbers, so 6 plus 8, that's going to be the 28th value. Cross out another 2, so I'm at the 22nd value at this point. So at this stage here, if I were to literally write down 6 8s, 3 9s, and 2 10s, I would have been at the 22nd value. The last 10 would have been the 22nd value. Crossing out 6 more, I'm going to be at the 28th value. Alright. Crossing out 2 more, I'm going to be at the what? 30th value. So the last value, 12, is going to be the 30th value. So what this means for me here is that the next 11 values will contain my 31st and my 32nd value. They're going to be the same number, 13. So my 31st value would have been 13, and my 33rd value, because I'll have 11 more 13s to write, I would have 10 more 13s to write. So 13 plus 13 divided by 2, that's going to still give me the value of 13. So my median value here is 13. Alright, and that is how you can easily find the value of the median there. Alright, if you have another method in which you think that you could have gotten the median value, feel free to leave it in the comment section below, guys. Alright, perfect. Let's move on to now part IV, part 4. Let's double check to see if there's anything around here that we have missed. No, we're good to go. Yes, I think I might have seen something here. Okay, we're good to go. Alright, now we're looking for the probability that a student chose not random had at least 12 answered. Now if you look carefully, that the word at least here is highlighted, right? So we need to know what the word at least means in the context of the English language, collaborating with math. At least means greater than or equal to, right? So at least, okay, so at least implies that we're greater than or equal to 12. Now, the next thing that we need to know is the formula for probability. So probability is equal to the favorable outcomes which is the amount of values that are greater than 12 divided by the possible amount of values. So we're looking for what? What are we looking for? At least 12 correct answers. So how many answers, how many students? Let's read this question again. The probability that a student chose not random has at least 12 correct answers. So we're looking for the amount of student that would have gotten 12 answers or more. So we know that since it's at least, it includes students who got 12 answers. So we know that 2 students got 12, 11 students got 13, 9 students got 14, and 10 students got 15. So I can safely say that my favorable outcome here is going to be equal to, favorable outcome is going to be equal to 2 plus 11, that's 13. 13 plus 10, let's check that again. So let's do 2 plus 9 is 11, and 11 plus 11 is 22. 22 plus 10 is 32. So 32 students would have been the amount of students who would have gotten 12 correct answers or more. But the probability would have been out of the 60 students. So the probability of me picking a student that has gotten 12 or more correct answer would have been equal to 0.53, or there's a 53% chance that a random pick would have been me selecting a student getting 12 or more correct answers. Alright, so that's a good chance, favorable chance. It's almost like a 50-50. Alright, but I have more of a chance of picking that student than the other. Alright, and that's pretty much how we go about looking at that statistics question there, involving a bit of probability and median and mode. Alright, so okay, so we do have another question on question 5 here before we move on to, let's see if the next question is question 6. Okay, so we have a lot more parts left. Let's continue. Alright, so here we have a group of students who wrote a physics examination. Each of the students achieved a grade 1, 2, 3, or 4. The pie chart below shows the results. So when I look at this pie chart here, what am I looking at? I'm looking at 117 degrees is representing students who got a grade 3, and this is also telling me that 39 students got a grade 3. Alright, so what can we do here?